In this video, we're going to explore why common algorithms work in addition and subtraction. An algorithm is just a procedure we use to carry out calculations. In addition, we often use the carrying algorithm. With the carrying algorithm, I line up my two values vertically by place value. And I'm going to start in the right column and add right to left. So I do 6 plus 8 gives me 14. Well, since that's greater than 10, I drop the ones place and I carry the tens place. And I keep doing that left to right. So this gives me 13. 13, I drop the 3, carry the 1. Then 1 plus 1 gives me 2. 234. Now, the reason this works, we have to explore using expanded form to understand. So I'm going to expand both of these numbers. And now I can add up each of the place values. So I get 1 100, 12 tens, and 14 ones. Now, I know that when I have 10 of any of the place values, I can combine them to make the greater place value. So I'm going to split the 12 tens into 10 tens and 2 tens, and I'm going to split my 14 ones into 10 ones and 4 ones. And now I can convert my groups of 10, so I have, and then combine like terms. So I get 2 100s, 3 tens, 4 ones, and when I simplify that, I get 234. Now let's look at that with base 10 blocks, as this is a great way that students can be using the blocks to help them. So first thing, I know I'm going to combine everything. If I combine 4 more ones together with the 6 I have above, that gives me a group of 10. And I can bring them over, and I can either line them up so that they're all perfect, or another way you'll see it is that you could just circle them so you recognize that this is a group of 10. Okay. Now I'm going to move my ones out of the way, so I know I've got 4 ones left over. Now look at all my tens. And if I count them up, one rod at a time, I'll see that I have 13 rods. So I'll move these two over. And I can say I can take my 10 rods here and move them over to the hundreds. And again, I can circle them so I recognize that all these individual pieces are collectively 100. And now if I look, I've got 100, 200, 10, 20, 30, 1, 2, 3, 4, 234. The same thing works with decimals, and especially understanding the expanded form can be very helpful. So if I expand out each of these numbers, I add up each of the place values. When I get groups greater than 10, I split them apart into a group of 10 and then whatever's left over. And then I'm going to convert them to the next place value. So 10 tenths makes 1 whole, 10 100ths makes 1 tenth. I combine anything that needs to be combined, so that I get 1 tens, 9 ones, 2 tenths, 1 100th, 5 1,000ths. Simplify, and I get 19 and 215 thousandths. I can do the common algorithm as well. When I line up, oftentimes if I'm missing a place value, I will put a 0 there to help me remember where the place value is. And often you'll tell students to line it up by the decimal. So 0 plus 5 is 5, 4 plus 7 is 11, drop the 1, carry the 1, 12, I drop the 2 and the decimal, carry the 1, 9, and 1. Now in subtraction, we use what's called the borrowing algorithm. And you can see we line up our numbers vertically by place value. But what happens if our minuend is smaller than our subtrahend, we borrow from the next place value to help us out. So in this case, we borrow from the 2 becomes a 1, and that changes our 3 to a 13. 13 minus 6 is 7. Now I'm looking at this 1 and saying, well, I can't do 1 minus 5, so I need to borrow from the next place value. Since I'm borrowing 1, that leaves me with a 0, and that 1 becomes an 11. 11 minus 5 is 67. Now when we talk about why is this working, the easiest way is using those base 10 blocks to help students explore. And what I'll often do is I'll make my blocks different colors because it'll be easier to tell what's addition, what's subtraction. Because what we want to do is we say that for every white block, we're going to remove a red one, and we want to make sure that when we finish with our number that there are no red blocks left over. And this is especially true as we're starting with just basic subtraction. When you get into negative numbers, you have to change the rules a little bit. Now, I need to still get rid of the red ones, so I'm going to break apart a 10 so that I can pull ones out. So I need to pull out 1, 2, I pull out the 3 ones, and it removes the 3 red ones. Now I need to do the same thing here. I remove a rod of 10, and so I remove 1 rod of 10, but I still have these 4 red rods. So now I have to break apart my 100 to be able to remove them. For every red rod, I need to pull out a white rod. So I pulled out all these pieces, and here's what I'm left with. If I pull it over, and I can pull them slightly apart so it's a little easier to see here. 20, 30, 40, 50, 60, and then 1, 2, 3, 4, 5, 6, 7, 67.